In the file system interface module, we have discussed about the directory structure and the types of directory structure such as single level, two level, tree, and acyclic graph. So, each directory in the directory structure has a set of entries where each entry is either for a file or for another directory, which can also be considered as a file. Now let's see how each of these directory can be implemented. The first type is the linear list implementation. Here, the directory is implemented as a linear list of file names together with the pointers to the data blocks. That is the location of the actual physical blocks occupied by the file. So what is the advantage of this type of implementation? This method is simple to implement. And what are the limitations? In order to create a new file, we must ensure that no existing file has the same name. For that, we should search the entire list. Similarly, to delete a file, we should search the directory from the beginning till we find the named file. Thus, the search operation is time consuming in linear list implementation. And after deletion of an entry, to reuse that entry, either we can mark it as unused using a bit, or we can attach that entry to a list of free directory entries. Otherwise, we can copy the last entry to this location and decrease the length of the directory. Since the time taken for directory search is the main disadvantage of this implementation, some systems use a software cache to store the most recently accessed directory information. So to overcome the main limitation of the linear list implementation, we use the hash table implementation. Similar to previous one, here also a linear list is maintained with the file names together with the pointers to the data blocks. But in addition, a hash data structure is used which make use of the file name as the key and computes a value which points to a location that helps to access the corresponding entry in the linear list. Thus, the search time is considerably reduced, but all the problems with the hash data structure exists here. There is chance for collisions if more than one file name mapped to the same location and the size is fixed. So we may have to enlarge the directory hash table and reorganize all the entries with a new hash function. Otherwise, one other option is each hash table entry can be implemented as a linked list to solve the collision.